Okay, my friends, get ready, get ready, get ready. Everybody wants to know, where do we find the gems? Where do we find the gold? Well, I can tell you where you find it. You find it in membranes, and you find it in veins and arteries. Now, can I explain and show and detail exactly what I'm saying? Yes, I can. Now, this is from Dan Hurd, and he put it up just a day or so ago. Huge payday after finding gem silica, and he's showing all this. Now, I relate this to biology because this is where it came from, and from I will explain exactly. And then I'm going to show you where the gold comes from as well, because that's what really turns people on. Okay, my friends, this is going to be kind of a little bit of a ramble and sort of quick because I got a zillion things on my plate. This is nothing more than that, only it didn't fill with gold. And the crystals didn't form the way they formed here. Now, why? Why is this not loaded with gold and silver, little crystals like that? Well, it was in a different entombment situation. So this layer of membrane, which is nothing more than a membrane, which is exactly what that is, instead of the center portion of the membrane filling with that, it just evacuated. Now let me show you how gold forms in every different biological type of blood vessels, and primarily you're going to find a lot of it in these membranes, and this is where primarily you're going to find most of the crystals. Not all, but a lot of them will be found there. Okay, my friends, let's just go through these kind of quick. Let's just start with the gold. Remember I showed you this shot. What is this right here? And the crystals and the separation. Why? Well, it's a membrane, and this is what a membrane looks like in a creature. So it has that layer turns into the crystals, both of these layers, and then in between it is a fluid-filled highway. And that fluid-filled highway, if it gets clogged up with gold here, it'll start to collect back. And this is in a membrane. And that's what we saw just uno momento ago, which is this. There's the top and bottom of the membrane, and here's where all the gold filters through. Now, gold will attach to itself and just sort of congeal. And what happens is it's due primarily to what they call specific gravity, which is how heavy it is. Now, I'll show you that in an artery. And here's the artery. Where's your artery? Here it is. Now, what you're looking at here is red blood. That's red blood. This was an evacuated tube of probably red blood at one time, because the red blood runs out. The black blood, which is the vein blood, does not run out easily. But you can see this was probably in this position right here. All right. So that blood was running down, and the gold got clogged up somewhere down here, and then it started to back up on itself. That's what happens. That's what I've found. And I do have some that have gold, and a lot of gold in them, actually. Well, not a lot, maybe, I don't know, some, maybe an ounce or two. And what happened with mine is there was an obstruction to where the main flow of blood comes out, and it's all packed in behind it, and it weighs a lot. So there's a lot of metals in there, and that's what happens with the metals. Now, this guy that I showed you earlier, well, first of all, make sure you understand this is where the membrane is. This is a membrane, and now those are all the little things you saw in the membrane, and there's the layer at the top, the layer at the bottom, and this turned into a lot of silicates in the membrane with no gold or anything. This one turned into a lot of gold in here, but some silicates. Now, and it all came from the fact that it was a membrane like that. Now, what else collects in there? Well, it depends on what's in the water. Here's what collected in this one. Look at that. Isn't that something? And this is the top layer, and then there's a membrane that protects this, which is the vital layer, which has all the tendon balls in it. Well, I call them tendon balls. They're really interstitium balls. And here he has taken all of these and sliced them all down. And that, you see this right here? That's the fluid-filled highway. This is what protects this layer of tissue from invasion from above. And he's slabbed it all out really nice. That's what he does, goes looking for crystals. And this was his discovery. And this shows above here is what they call a capstone, and then you have the layer of membrane. And down here you can see, if you know what to look for. I do. This is the interstitium, which is directly below that layer. Where else we got here? Now, this is the kind. I mean, this is it. These are layers all over the Earth. All those are layers of membrane. The things that are on the Earth are absolutely stunningly large. Stunningly large. And that because I believe there is nothing but biology. Now here's an artery that came down. These are the little blood vessels that come off, and the blood just collected in here because it got capped off somewhere down in here. And here's another one right here. They call this a wire. That's nothing more than an artery coming down, shooting off the blood vessels. It gets clogged up at the end. You can actually see the red blood here. If you look, if they really looked at these closely, they'll find blood in these. There's blood in amongst them. Now look at this. This is fascia. You see all these little, they call them gold wires, wire patch mine. This was fascia, which is nothing more than part of the interstitium. All of those little wires went to little stone balls. That the balls in this case went away, and the golds, the wires stayed, the little straps. It depends on the chemistry it's in. Sometimes it's all due to something called nucleophilic substitution. See this? This is blood. That's your red blood, that's your black blood, which is arteries and veins. See it squirting through here? This is all where that came down and got clogged up somewhere down here. And then the gold starts to build on itself in the arteries or in the veins or wherever it happens to be clogged up at. So there's really no saying where you're going to find the gold. Here's some this is a fingertip. That's literally a fingertip. And that's why fingers are so saturated with blood, it's absolutely amazing. And this is where the blood is coming in the center of the fingertip. And as a matter of fact, I have one here. It's from a giant. Hold on. You want to see how identical that fingertip is to mine? Watch this. It's exactly the same. There's no difference. Now, the blood gushes out. There's a patch right in here where it's just dense with blood. And there's the pads, of course, on the bottom. That one there, you're just seeing the top of it. Just like this. You see that little cleave right there? That's this right here. It's the exact same thing. This would be so saturated with blood, it'd be just like that. That's how much blood is in fingertips. I had 2 DNA tests done. Both were from fingertips. This one here, and had another one much larger than this. And both of them came out human DNA. And then I had also this. Here it is. This right here is the same as those gold wires. Remember you saw the gold wires, those little straps? This is what happens with that. This stuff would have turned into gold. But this I also had DNA tested, and this was human. And it's saturated with blood. Saturated with blood. And this is the little strap that carries the interstitium fluids to the rest of the body. This is what's causing, I finally realized the interstitium appears to be the layer where that gold collects, mostly, and in the blood. But you remember this, don't forget this, and you remember this. That's got as much blood as you could possibly have in something. So, I don't know if I've made my point yet. Now, let me show you something. Remember I showed you the membrane right here? Well, I have a friend out on the West Coast, Tyson. And he's got Tyson's Mudfossil Adventures. And this is a membrane. Remember what this looks like. Remember these channels that go through here. And this little curlicue thing. Well, look what he found out on the West Coast. That is a membrane, and it's a bilipid, so it's got one layer down here and then that gooey stuff which all eroded away, and then there's another layer up here. Guess how far up it is? 6 feet. All right, Kavish? 6 feet. So this layer we were just looking at, the holes are down here, and then there's another layer up on the side of the ocean wall there, where all this stuff has been eroded away, and it's up here 6 feet up. So these things were just, I mean, I can't account for it, so don't scream at me. They're here, and as you can see, these are the membranes of some gigantic creature. And I mean, when I'm talking about gigantic, I'm talking about thousands of miles long. And this, my friend, is specific gravity of different transition metals from blood. All right, I'm going to probably leave it at this for today, because I'm going to get very, very deep into this. But this I show because everybody seems to get tripped out on it. This is the pili erector muscle on a hair follicle, and that makes your hairs go like this. This is the sebaceous gland, vein and artery. Hair grows up and comes out the top. That's I forget how big it is. I thought it was maybe 500 times, somewhere around there, bigger than a human hair follicle. Maybe 250, I can't remember. This stuff gets hard for me to remember. I think I'm losing my mind sometimes. Okay, my friends, as I just showed you how big these creatures were, this is even from a small one, and this is a hair follicle, and that's where the muscle attaches, right there. This is where the sebaceous gland is, right there, and that's the hair that comes up. This is the root, and that's the two vein and artery, the two little dots. This is a hair follicle from a very, very large creature, but nothing nearly as big as what I was showing you in some of these pictures. This, my friends, like from Tyson's, fine, he's got all kinds of stuff. Tyson's Mudfossil Adventures. Now, and he's doing some very, very good work up there. And he's got a drone, and he's going out looking around. So you can go up there and watch what he's presenting, which is all the same stuff from giant creatures. So there is nothing but giant creatures. He's got a real nice spot where it wears down the side of the mountain, and he can, well, I guess you call it a mountain. It's the side of the cliffs along the ocean out there, and but this stuff is everywhere. It's not. There's no special location. There's places where you can see things much better. But the Earth itself is created of biology. I have found nothing that is not biology. The Moki marbles, all of that stuff is from biology. And it's time we pay attention to what really is on our Earth and what our Earth is constructed of and what the ancient texts say, and not continue to just ignore. And here's all the different transition metals. And see all these different colors? Well, that's why we see this stuff like this. Those are your blood has all of those different transition metals in it. And I think I'm starting to focus in on the lymph now. It may be much more related to the lymph than it is the blood. It's an aqueous solution. Well, here's what it says about transition metals. They form colored compounds and complexes, and they vary depending on the charge. See, they find each other because of these charges, these oxidation states. Now, they're called ligands, and they attach to the metal ion, which is, say, the gold or the silver or the copper or whatever it is. So they attach to the metal ion in watery solutions, aqueous solutions. The ions, which are these charges, form complexes. So they start to grow in these different colors and, congeal because of these potentials, these electric potentials, basically. They find each other. So hopefully that helps to clear things up a little bit. But I'm going to get very, very deep into this. I got the microscope all fired up, and I got to really show some of the deep details of the membranes, because the membranes are now, I'm focused in on those pretty close. And again, these are something, this is not even was known really until 2018. They made a paper about this interstitium, which is this layer that protects you. And it's a membrane, but there's more to it than just being a membrane. So that's what I'm digging deep into now, which is the medical, research that follows this interstitial layer, because it's been declared a new organ system, the biggest organ in the body. Didn't even know about it until 4 or 5 years ago. All right, I showed you where the gold and all that stuff collects in that membrane. I showed you the membranes. Meet your interstitium, a newfound organ. This is in 2018. They published this paper. And this is the layer we're talking about right here. This is the layer that has the immune cells and the fluid-filled highway. And this, I believe, is where this fluid-filled highway is the place that's collecting these different minerals and metals and so forth. I could see it's also in the veins and arteries. There's no question about that. I guess it collects anywhere where it can settle. But this is in one of these membranes. But we also see they can be in blood vessels. All right, but there's no question about that. That's absolute fact. Because this one right here, that's red blood, and then the metals settle down because of specific gravity. Here the blood stops and the metals filter down because they're the heaviest stuff. It's specific gravity is what it boils down to. And then this is right in the interstitium. It's nucleophilically substituted these I call the straps. The balls eroded away, because these little straps all attach to little balls, and I could show you that in my belt. Any leather has the same thing. They have little balls and these straps attached to them, and that's how the leather can bend and do all that stuff. And in this case, it turned to gold. So there is no set definition as to where gold can show up, but it always settles out from the blood. Simple as that. And fingers and toes are where you got a ton of blood. And when they're in the right position, I have one here. Well, I might as well show it to you. Hold on a second. Okay, here's the deal. This is a toe, and this is the callus on the side of the guy's toe. This sucker is like this thick, and this capped the red blood from coming out. This tried to run down through here. This is the vein. Veins never blow out because they have caps. In this case, the artery ran down, had nowhere to go because this cap, which is literally the guy's callus, capped over the red blood side. You see how this one side is going to be red blood, the other side is going to be the vein blood. The vein never blows out because it has valves. The red blood just explodes right out of there. Well, this time that capped it right off. This is saturated with gold. I don't know if you can see all those little sparkles in here, but it's saturated behind here with metals, and this thing is heavy. Now, this side here is all the black blood. See, they would never ever do that normally. And this is that scuffly little stuff that's in the bottom of your big toe where it touches up against the other toe. It has that little scuffy looking spot. Now, this again never ever 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 would happen if that other side was open, because then it would have blown. Oh my God, this thing is heavy. Hold on a second. I'm not strong enough to do this anymore. I'm going to tell you that right now. Hold on. Take it easy. Let me get it set up. Hold on. All right, this is where, again, they're just flush with blood. There's a flush blood spot there. There's this up in here is where the tendons all locked together. It's like an apical tuft. This is literally where the toenail was. And this again is the callus. That strap right there, they all have that. It wraps around. It's called tunica. And that's where the blood, the vein tried to force its way out, and it really forced its way back. That's the black blood never blows out like that. It just never, ever, ever does. And here's the top of the where the fingernail was. So toenail, I'm sorry. And then, of course, on the bottom, we have all the grip skin. You see that? Let me see if I can come up close to that. First of all, you have that gnarly little spot that you have on the bottom of your foot, too, and on the bottom of your toe. And then all of that little fibers, those little fibers, that's the grip skin. Very, very, very tough. You see that? That's the bottom of the guy's callus. From here down is callus. I'm not kidding you. I mean, I get calluses, but not like that. Now, that's the bottom of the guy's toe. What can I say? This is what it is. And again, gold can collect anywhere. And I'm going to tell you what. There's going to absolutely no question whatsoever be a lot of metals in here. Now, can you see all right there? If I put in a microscope, you see all these things. They should be sparkling and everything. You should see a lot of sparkles. But right in here was what capped it off. Otherwise, it would have run out. And there's gold in everything. There's gold everywhere. In the dirt right in your backyard, there's gold in there. But it's just so tiny because it runs down to the little molecular state. Well, when it starts to congeal on itself, as I showed you in all of those other pictures, then it's a whole different story. It starts to build. Look at that. Isn't that something? Look at that. That's what they call cornified skin. There's some gold right there. Once it collects, whole different story. So anyway, I hope that is a little bit illustrative of how these things collect as they run down. And normally this thing's going to be down that way and it's going to run and splash out. And the red blood goes right out. The black caps off. Okay, I showed you that other toe, and it had one big black spot on the bottom. It was on the left side. Well, this one here, that's the vein where it turns black. And this is the tendon that goes to it so you can move your fingers. Now, this is a thumb, actually. And this is and that's this right here. It's a thumb. This one right here. That's the bone. This is a CAT scan. And that is the tendon that runs up this side, and this is the tendon that runs up that side. One is fed with a vein, and one is the artery. And artery brings the blood down, the vein brings it back. And I told you, they never run out, they cap off. Virtually never. You see, these are capped off. And even the red is capped off because the blood was running down this way and this way. If it was running down this way, the red side would have blown completely out and the black side would have capped off. And this is exactly it right here. There's another fingertip from, a fairly good sized giant. And this here is the black side. They don't blow out. They have caps. And the same on the end, it has a cap. Well, what about here? Totally different story. Blows right out, blows out, and blows out. There's a 2 and a 3. Pew. That was a fingertip. This side doesn't blow out because it's capped off. They have valves. And this died in the flood too. Flat like a pancake. Almost all my stuff is flat. Even Caesar Augustus, my good friend Caesar here, a goose. There's his feathers, and it's solidified like this. And I understand the whole process now, and I understand I understand everything about it now. And then if anybody wants to know about it or wants to talk about it, I'm here. And I showed you these, how big, I have them coming out of my ears. In my backyard, I have a 3-foot long fingertip. Still has a fingernail on it, and a fingertip, fingerprints. So, and these aren't even big now. The stuff that's big is so big, the human mind cannot even encompass it, just can't take it in. These are like multiple states they cover. I'm not kidding you, multiple. So it's time to either open your mind or just go back in the woods, one or the other. Okay, my friends, next video probably that I'll be doing will be about this colored lake up in Canada and some other places on Earth, and what makes these strange patterns and formations and colors and all that. And I do have explanations, I believe, that are valid. So let's see if they make sense to you. All right, so stick around, just stay, subscribe. Please give me a thumbs up and share these things. Don't be afraid to talk to other people about this, because they'll call you crazy, but trust me, you're the one that'll be the smart one in the end. They'll say, boy, we should have listened to Bobby. He was really on top of this stuff. Trust me, if you hide in the woods like everybody else, then, that's just the way it's going to go for you. You'll be just like everybody else. Well, I think you should start to pay attention to this and mention it to people. Let them, and just say, what do you think? Don't tell them, here's what it is, this is it. I do that. But just you tell them, what do you think? Don't make it even a commitment. Say, I don't know, this guy could be insane. And then just leave it at that. And then that will draw them in to say, yep, the guy's crazy. Well, make sure you take it a little easy on them so that they give it more than a few minutes, and then they can make their own determination. But that is the first thing that'll happen is that, the guy's nuts. Hey, well, what are you watching this for? You're a nutcase. Well, that may happen, but you're going to find a few that won't do that, and now you'll be understood as the one that took the time to understand what they were looking at, and not just follow the crowd like one of these. Okay, my friends, you can go around walking around looking like this if you'd like. I think this was from the Yale graduation. They all went down there to get their sheepskin.